Those are online, are able to hear me?
Yes, sir.
Yes,
Sorry,
sir.
I got the workshop, so I had to complete. Sorry for the delay. I just is it there? Bhaskar, cameras. Sorry, not the late one. Right? So can we just revise the topics that we discussed the previous class? Yeah. So can you tell me what were the topics we discussed in the previous class? Just go through your notes. Yeah, I asked a question, man. What did we discuss the previous class? Connect. It's. Yeah. Can you tell me? So what is the free body diagram? Can you tell me what is the free body diagram? Forgot. The black t-shirt. Solra. Diagram. It's an insult to me. அப்படியே சொல்லி கொடுத்தேன் நான் அப்படியே சொல்லி கொடுத்தேன் diagram நான் சொல்லி கொடுத்து அப்படியே சொல்லி கொடுத்தேன் I told you how to break physics and understand the grammar bit பேர்லயே இருக்கு நான் எத்தனை வாட்டி சொல்லி கொடுத்தேன் மெமரைஸ் பண்ணி புக்ல இருக்கிறது அப்படியே நான் சொல்ற மாதிரி சொல்றேன் மேன் என்னாச்சு உனக்கு அதனால டென்ஷனா? கமா மாத்தி போட்டியா? பங்க்சுவேஷன்லாம் பாக்குறாங்கடா பிசிக்ஸ்ல. எங்க போட்ட கமாவை? அது நீ எங்க போட்டேன்னு ஃபர்ஸ்ட் சொல்லு, நான் கரெக்டா இல்லையான்னு சொல்றேன். என்ன என்ன போட்ட, எந்த இடத்துல? சரி, எப்படி போட்ட சொல்லு. அதனால மாறிட்டேன்ற. ஒன் கமா சேஞ்ச் யுவர் லைஃப். Can you tell me what is the free body diagram? Just break the name. No, I told you what is the significance of it. I've already explained it. Just try it. I don't want any book. There is no book definition, first of all. So why do we draw that in the first place? Why is the free body diagram needed for us? Basically, we try to understand what are all the forces acting on an object. I used the word, you remember, I used two important words. One is called as a system and surrounding. Right? What is a system? So objects that are under observation is called as a system. Anything other than that is going to be a surrounding, right? So when I talk about a system, right? When I talk about a system, for example, I think I explained with respect to a remote control, right? When I place it on my hand, what is going to happen to it? If I'm going to keep it at this position, right? What are all the forces acting on it? Gravitational force is acting on this due to whom? So you always need to add or ask a question. The force is acting due to whom? See, why I'm telling this is, I'm just sharing the way you're supposed to think. Okay, if you think in this way, physics, all other chapters is going to be the same thing. So whenever you talk about a force, what is the first question you need to ask? That force is acting on that object due to whom? So you told weight. So weight is acting due to its own mass. Weight is mg, right? So weight is acting due to its own mass. So what is the other force acting on it? I told last time, there is a reaction force. What is the name of the reaction force? Something that starts with N. It's called normal. Why do we call it as normal? The normal means perpendicular, right? So it is going to be perpendicular to the surface in which the object is in contact with, right? So that is acting on this object due to whom? Normal is acting on this object due to whom? Normal itself is a reaction force. Who's applying the force of N on this object? My left hand. It is due to the surface of contact. So that is why if you see the definition, how did I give it as? What is the definition I gave for normal? It's a contact force offered by whom? Offered by the surface with which the object is in contact with, right? And how is it going to act? It is going to act perpendicular to the surface. That's why you call it as a normal force, right? In a similar way, you have another force. One other reaction force that we discussed is tension. So when does tension come into picture? So normal ki I think tension, you would have forgotten tension. Last week, I'll start from there. Okay, we'll start with tension. Okay, so let's observe this. I don't have that object in my hand. Let's take a charger. Okay, let's take this. Right, so here there is a block that is being suspended. Right, so 1 minute. So here, let's assume there is a block that is being suspended, right? So if I take this block independently, what is going to happen? I'm holding this here, right? So first, let's forget about this string. Let's come from the beginning. If this is an object of mass m, in which direction is the weight of this object going to act? Obviously, in the downward direction. So if I just try to project it here and observe it diagrammatically, right? This is the adapter, right? You have this. So what is the direction in which the weight is going to act? Downward. Now the question is this balanced or not? Is this balanced? Why? Because I'm holding it. Okay, by me holding it, how is it balanced? What is the science acting? What are the science behind this? See, there are two ways I can make it get balanced. Observe this. Weight, if I'm going to keep it like this or like this, it is going to be the same thing, except so in both the scenarios, I'm balancing it, right? So I am able to balance it in the air or I keep it on my hand. In both the cases, its weight is acting in the downward direction. Okay, accepted. In this case, what is the balancing force that is acting to stop the object falling from its own weight? In this case, it is a, what is the name of the reaction force? Normal reaction force. Whereas if I hold it like this, is there a normal that is coming into picture? Then who's balancing it? Who's balancing it? Observe what is happening. What is there between my fingers and this all? So what? Tension. It's not tension. What force is there? Weight is also a force. Pressure is not force. Force per unit area is pressure. I'll give you a hint. If I apply some oil here and try to hold it, it will fall. This friction. So there is a friction acting between my both fingers in the upward direction that such that the sum of these two frictions is balancing the weight. Accepted? Are you able to visualize? Now the question is, instead of friction, if I take this charger and with the help of a string, if I try to balance it, is it getting balanced? Ignore the fact that it is swinging. Is it getting balanced? Now I don't have any contact. The same mg is acting in downward direction, but still I'm able to balance the system with the help of a material, with the help of a medium called as a string. So what am I doing here? Or what is the string doing in the first place? So if you see, the string is there, no? At this point, observe, at this point, what is happening is mg is acting downwards. So when mg is acting downwards, the topmost point which is in contact with the bottommost point of the string will also get pulled downwards. So you have to observe it on a molecular level. Observe, if there is a molecule here, if I place a dot here, in which direction is the dot going to get pulled? Downward. So this block is trying to pull the dot in the downward direction. But what is the string trying to do? String is saying, I'm not going to come. So it is trying to apply an upward force. So what is the name of the upward reaction force it is offering near the point of contact or near the point where it is tied to the object? This is what is tension. Okay, don't get confused. Tension comes into picture when there is a string connected to a solid object. Normal comes into picture only when an object is in contact with another solid object. So here there is no contact. It is in the air. Are you able to understand what I'm trying to say? It is in the air. In this case, there is no concept of normal unless there is a surface which is present at the bottom. So don't get confused between these two. The reaction forces come into picture based on the way we offer the action. Here, what is the action that is acting on the object? In all the three scenarios I discussed, what is the action acting on the system? It is its own weight. When I kept it on my hand like this, what was the reaction force offered? Normal, which was balancing the weight. When I held it like this, the same weight is acting downward, but what was balancing? Friction. In the third example that I considered, so I don't have any contact directly with the mass, but I used a medium called as string to balance it. So in this case, tension is coming. So this is the tension, right? So one more thing that will happen is I held it at a point, right? I'm holding it at a particular point. Let's say this point is this. I'm holding it at this point. So what will happen is at the bottommost point, tension is upward, whereas this point will tend to get pulled downwards. Means this block is actually trying to pull my hand also downwards. See, if I replace this mass with a heavier mass, which I'm not able to hold with one hand, I don't know what is the threshold going to be. So what will happen? My hand will get pulled down like this. Why is it happening? So is this directly contacting me? No. Through this mass, the tension is getting transferred. Yeah, fine. Okay. So through this mass, the tension is getting transmitted to the other part of my hand. Right? Here, what will happen is my hand is getting pulled in downward direction because of the same tension. So what will happen with respect to a string? is going to be in such a way that the tension at both ends of the string will exactly act in opposite direction. So this kind of a force is called as an action reaction pair. It's called as an action reaction pair. So when you look at the string itself, no, at the bottommost point where it is in contact with the block, the tension is acting upwards, whereas exactly in the opposite end, it will act in the downward direction. And both the values, note this point, both the values will have the same magnitude T.
Sir,
Yeah.
the direction opposite to that, which is in contact with the object, is it where you're holding the string?
Which one? That line I put like this, no, that one. No?
That is where you're holding the string.
That is where I'm holding it. This is my
Yeah.
hand. This is my hand.
Okay.
Got it? Yeah. So are you able to get some perspective out of this? Are you able to visualize? Right. Now the question is, listen to this. So whenever we talk about the tension, right, the concept of tension in your physics is applicable for a string, which is basically massless and inelastic. In the sense, it does not have any extension properties. The string should not get extended. If it is getting extended, the tension will not be the same. So in all the problems that we are going to do, even though it is not given as the problem, it is assumed that the string is going to be massless and it is inelastic. If they need to give it that it has mass, they'll mention it in the question. At that time, things will change. Okay, so whatever concept I told you with respect to this action reaction pair is applicable only for this, and please make a note of this point. Right? Now, having all the story in mind, let's see what is the definition of it. Tension is defined as the force that is transmitted. Are you able to understand what is the meaning of transmitted? I told you, my hand is getting pulled down. How is it getting pulled down? From the block, the mass, the force is getting transmitted through the string medium, and my hand is being pulled down. So that is the meaning of transmitted. So it is transmitted through a rope or a string or wire. So that's why I took a wire into consideration when pulled by forces acting from opposite sides. So what do they mean is, this force was pulling in the downward direction. This force, my hand was pulling the object in the upward direction. So the string is actually getting pulled in opposite directions. Though my hand appears as if I'm holding it, but actually I'm trying to pull it up. If I release it, no, it will fall down. Then there is no concept of tension. Are you able to understand this point? So when the string is pulled by forces acting on opposite side, and next point that you need to notice, the tension force is always directed over the length of the wire and pulls energy equally on the bodies at the end. So here what is happening? It is pulling in this direction. At the top, it is pulling in the downward direction. So tension is always a pulling force. It is never a pushing force. What happens with respect to normal? What is normal trying to do? When normal is actually pushing, whereas tension is always pulling. Are you able to understand? So this is a very, very, very important point. I want you all to make a note of it. Okay. Done with this? Yeah. Those who are online are able to understand?
Yes, sir.
Yeah.
Yes, sir.
Will I proceed? Listen. Now, let's do some problems that are based on these concepts. So next topic will be problems based on FBD, that is the free body diagram, right? We'll see the problems based on free body diagram, right? So listen to this. Let's say on a fixed surface, right? There is a block of mass m that is lying, which is pulled with the help of a string, right? So we need to calculate the acceleration of this block. So what do we need to calculate? We need to calculate the acceleration of this block. So this is a very, very simple problem. Okay. So whenever you're dealing with problems based on free body diagram, I would like to give you some steps that you need to follow. Right. Steps to be followed. Right. Steps to be followed. First thing is draw the free body diagram for all the particles or objects in the system. So first you need to draw the free body diagram of all the particles or objects that are there in the system. Second is assign proper directions as per coordinate geometry. In the sense, you will consider one direction to be positive, other to be negative, right? Why I'm telling this point is when you try to draw the free body diagram, in free body diagram, what are you actually representing? You're representing the forces. So forces are vector quantities. So for vector quantities, you need to assign proper directions, right? So third is apply Newton's second law on each object. So apply Newton's second law on each object, where the external force is equal to mass into acceleration. Fourth, solve for the unknown. Okay. So am I clear with this? Right. Now, having said this, on this object, what is the first step I need to do? I need to draw the free body diagram. You take this to be mass. There is tension acting in this direction. There is mg acting downwards, right? There is a normal force acting upwards, and there is acceleration in this direction. Is that clear? Right. Now, if you see, this is the first step. So did you understand what I did here? On mg is acting downwards. Why did I draw normal in the upward direction? Because it is in contact with the horizontal surface. And what is happening in the rightward direction? It is tension that is acting. Because whenever you think of a string, the first force that you need to apply is tension. Okay. Now, what is the second step? I need to assign proper directions, right? As per coordinate geometry. So what I will do is, since this is a horizontal system, what I will take is, I will take the basic coordinate system like this as reference, and I'll take anything in the rightward side as positive, anything leftward is negative, anything upward is positive, anything downward is negative. Simple. So to put it simple, tension here is going to be positive. Normal here it is going to be positive. mg here it is going to be negative. Acceleration is going to be positive. Right. Now, if you observe, you need to check for the motion in each direction. So if you check for the motion in y direction, actually, when I told apply Newton's second law on each object, right? One point I would like to add here is in each direction. So just add that point of in each direction, meaning I need to apply the Newton's second law in the y direction separately and x direction separately. Is that point clear? Now, when I do this, I'll get n plus minus mg is equal to mass into acceleration along y direction. Am I right? Why did I write y here? Because I took all the forces along y direction. So I will say along y direction, there was all the forces that are acting. So what is acceleration along y direction? Is the object moving along y direction? So when the block is placed, it is moving only in the horizontal direction. There is no motion along the vertical. Along vertical, it is balanced. So what is the acceleration along y direction? It is going to be 0. So mass into 0. So n plus of minus mg is equal to 0 means n is equal to mg. So in this case, what is happening? Along the vertical direction, it is balanced. See, as you are experienced, right? As you gain some experience in solving problems, you need not write it like this. You can directly go with Newton's third law. You will know whether the object is moving or not. Directly looking at that, you can say n is equal to mg. So in which direction is the object moving? In which direction is it moving? I have already put it here. It is along, no, which direction in the sense horizontal or vertical? Horizontally, it is moving. So if I apply it along horizontal direction, right? If I apply it along horizontal direction, then F external, what is the F external acting on it? T is equal to mass of the object is m into acceleration. So what is going to be the acceleration here? It is going to be T divided by m. Are you able to understand this point? Is that point clear? So it is a very simple problem actually. Right. But when we start extending this concept to multiple blocks connected with the help of a string, these steps will come into picture. So whatever I've given here are the generic steps that you need to follow to solve any problem that is based on free body diagram, any problem. So if you see whatever problem I solve, I'll not go beyond these 4 steps. I'll solve and show. Is that clear? Yes. So make a note of. So let's see another example where there are two blocks of mass M1 and M2 which are connected with the help of a string, right? So if you take the force into consideration, let's say there is a force applied on the system which is pulling the system to the right in this example. Okay, I'll just make a small change here. Thing is, I'll take this as M1. I'll take this as M1 and this as M2. Okay. So there is a force that is pulling these two blocks which are connected with the help of a string. So here, how is the string? There are two things. String is massless and inextensible or inelastic. Means it cannot be extended, right? Now the question is, what is going to be the acceleration of the system? Right. So I have a question here. Since this force is directly applied on M1, can I call this acceleration as A1 and I'll call this acceleration as A2? Can I see? So are you able to understand? Because this force is acting directly on M1, it is A1, and this M1 is pulling this M2 through with the help of a string, so it is A2, right? That is the first mistake. Because observe. What will happen is, observe. Let's say there is a string which is pulling, right? If this is inextensible, the meaning of this is, if this is inextensible, if this is M1, this is M1, my left hand is M1. If this is inextensible, with whatever force I'm trying to pull this, the relative displacement between these two should be 0. Means if this is moving, this will also start moving. If this is moving, this will be at rest only if it is extensible. Only if it is loose like this will first become tight and then start pulling it. But here what is happening? It is already tight enough. So due to which, when this starts moving, this will also start moving parallelly in this way. Are you able to visualize what is the meaning of it? Right? So the first mistake that we are not supposed to do is saying that the acceleration of these two blocks is different, rather it is the same. Is that point clear? So here the correction is A1 and A2 are the same. Did you understand why is it so? Because there will be no relative distance of separation between them. There will be no separation. Why? The length of the string is constant. I'll prove it and show it mathematically after few classes. Okay. We can solve it with something called as constraint equation. I'll explain it to you with the help of differentiation. But as of now, I hope you understood the logic. Why is this happening? Why is the acceleration of both the blocks the same? What is the reason for it? Because the string is inextensible. Inextensible. Meaning, if this is accelerating at a different rate compared to this, then we are trying to say that the string is becoming loose and tight, which will not happen at all. Is the point clear? Now, so since both the accelerations are same, what did I tell you? The first step is draw the free body diagram for each object present in the system. So when I talk about each object present in the system, for M1, if I draw a free body diagram, it is going to be M1G downwards, and there will be a normal reaction acting upwards. It will be N1, right? And this is going to be F. This is the force with which the object is pulled. But what is happening on the left-hand side, unlike the previous cases, left-hand side, you have a string. Left-hand side, you have a string. This is the string, right? So what will happen here is, since the force is a pulling force on this side, the tension will start acting exactly in the direction opposite to this. Meaning the tension will be in the left side direction. Is the point clear? Is the point clear? Right. So are all the forces done? N1, M1G, F and D. So what is the acceleration of the system? It is going to be A, and that is what we need to find. We need to find the acceleration of the system, not with individual blocks. Acceleration of the system is the same as the acceleration of individual blocks also. Is the point getting registered? Next, if I take this to be M2, right? If I take this to be M2, now M2 is being pulled only with the help of a string. Now, since for the same string, near the other end, the tension was acting in the left-hand side, on the other side, it will act in the right-hand side. So in this case, the tension will act in the right-hand side. Now, I have a question. Should I write it as T1 and T2, or should I leave it as T itself? So should I write it as T1 and T2 or leave it as T itself? How many of you say T1 and T2? T1 and T2. That is another mistake. I know others, those who didn't raise the hand don't even know. You are completely clueless. You don't laugh at them. Okay, they were at least bold to raise their hand. Next. So you should not write the answer as T1 and T2. You should not write the tension as T1 and T2. It is the same T. So how to find whether it is 1T or 2T is the number of strings in the question is equal to the number of tensions. So how many strings are there in this problem? One string. So there is only one tension. Let it be. But still it is inextensible. What did I tell you when I explained tension? What did I tell you when I explained tension? When you draw the diagram, you remember this concept which I explained. So for this string, if at one of the ends tension is acting upwards, exactly on the opposite side, it will act downwards and they both will be of the same magnitude. This is what I stressed upon. So same thing is what you're doing. If you join these two and see it here, right? Actually, what I did is I wrote the tension here as T and here as T. Just tilt it in the horizontal direction and see, are they both the same logics? So what is the hint here? Number of strings in a problem is equal to what? Number of tensions. So here there is only one string, so it is same tension T. Is it clear? Now, for the second block, what is the direction of acceleration? It is rightward. All right. So are we done with the free body diagram? Are we done? No, because I didn't draw M2G and N2. So now we are done, right? So this is the first step, drawing the free body diagram for each object present in the system. What is the second thing? You need to assign the direction. Since again here it is a horizontal system, what you do is you take the basic coordinate system such that right side is positive, left side is negative, upward is positive, and downward is going to be negative. So out of all the forces available here, what forces are positive? So rightward, this force is positive, this one is negative, this one is positive, this is negative. Similarly here, positive, positive, negative. What about acceleration? Acceleration rightward, no, so it is positive. Here also it is positive. Makes sense? Okay. Now, how to apply the Newton's second law? So we are done with assigning the direction. What is the third step? The third step is applying the Newton's second law to each object in the system after you draw the free body diagram. Right? So when you apply it, but for that also I told you something. You need to apply it along horizontal and vertical. So for this problem, I'm not going to apply along vertical because our objective is to calculate the acceleration of it. So acceleration, since it is taking only the horizontal direction, I'm just directly telling you that along vertical, all the forces are balanced, meaning N1 is equal to M1G, N2 is equal to M2G. So that's balanced because the object is not accelerating along Y direction. So we'll same thing. It's balanced only in the previous case. Check. That's what I gave. I gave N is equal to MT. It is balanced. Since it was the first problem, I explained it in detail. Here, since we are only interested to calculate the acceleration, we'll apply the Newton's second law of motion only in the direction in which acceleration is there. Is the point clear? So having said that, for the first object, so what is the mass here? It is M1, no? So for the first object, what is going to be the force? What is going to be the unbalanced force which is causing the acceleration of the system? What is the unbalanced force? It is not force F alone. It is F minus T that is causing the object to accelerate. When I say unbalanced force, think of it like a tug of war. This side force is more compared to this side. There is a force in the leftward direction also. Are you able to understand this point? Right. So when I told you apply F external is equal to M into A, I'm talking about the net force that I'm speaking about. So net force acting at the direction is equal to mass into acceleration. So here, what is the net force acting in the horizontal direction? It is F minus T. Did you understand why it is minus T? Because T is taking a negative sign. F minus T is equal to MA. There is a small correction I need to do. What is it? It is M1A. Because that is what is acting. It is M1 into A. What about the second one? Tell me what is the unbalanced force that is acting in the horizontal direction? Look at all the forces along horizontal. How many are there? How many horizontal forces are there? In this case, there is only one. So that is the only unbalanced force. So T is equal to M2 into A. So F minus T is equal to M1A. T is equal to M2A. Take this and substitute it here. F minus M2A will be equal to M1A, which implies F is equal to M1 plus M2 into A, or that also implies that A is equal to F divided by M1 plus M2. So acceleration will be equal to F divided by M1 plus M2. Is the point clear? Right? Just make a note of it. So 1 minute. They can ask you another question also. Apart from acceleration, they can ask you what is the tension experienced by the spring, or what is the tension created in the spring. So for that, what you need to do is T is equal to, you look at the mathematical equation. T is equal to, I have this equation where M2 is known quantity. M2 into, in the place of A, I can substitute this value. So what will be the answer? So it is going to be M2 into F divided by M1 plus M2. So T is equal to M2 into F divided by M1 plus M2. Is the point clear? So acceleration is like this, tension is like this. Okay. Very good, huh? Let proceed. Listen to this. Done. Listen. So third problem is similar situation, right? Similar situation, but now we have three blocks instead of two. Okay. There is a force that is acting on the system, and the first and the second block are connected with the help of a string. Second and the third are connected with the help of a string. Okay. So all that we need to calculate is what is the acceleration of the system. Now I hope you all are clear with the fact that M1, M2, and M3, everything will have the same acceleration, right? Similarly, the strings are massless and inextensible. Now what I want you to calculate is find out the value of A and tell me. Mhm. 2T in the sense that you have to tell me. I told you all. I gave you the answer. You will write it as 2T's or 1T? 2 or 1? Why are you confused? I already gave you the answer. Correct only. It's 2. So I'll write it as T1 and T2. How many normal forces will act? 3. See, if you observe, though it is the same surface of contact, right?
Sir, is it M1 plus M2 into force divided by M1 plus M2 plus
Come again. For what?
M1 plus M2 into force divided by.
You are giving the answer for tension. I didn't ask you.
Oh
for,
yeah, I'm giving answer. Sorry, sorry. I thought.
I'm asking for the acceleration. What is the answer? What is the acceleration? Anyone? Try. What is the answer? Minus listen. So if I take the block of mass m1, F is acting to the right and there is tension acting to the left. So since there are two strings, you will call it as T1 and T2. Okay. So here I'll take it as T1 and let this acceleration be A. So F is positive, T1 is negative, acceleration is positive. So what are all the other forces that are acting? M1G downwards and N1 upwards, right? So what is the unbalanced force putting the system into motion? So the difference of force and tension. So can I write F minus T1 is equal to M1A, right? F minus T1 is equal to M1A. Now, similarly, if I look at the second block, if I look at the second block, M2 is attached to two strings, right? So there is a tension acting in the rightward direction. There is going to be a tension acting in the leftward direction. So rightward direction, we'll call it as T1 because for the same string on the other block, it was acting in the leftward direction. So here it should act in the rightward direction, right? So what about the tension here? It should be in the leftward direction. So this is positive and this is negative. What is upward? N2 is upward, M2G is downward. Is the point clear? So T1 and T2 are like this. In a similar way, what we can say is, tell me, T1 minus T2, because the object is still accelerating in the rightward direction, which is positive. T1 minus T2 is equal to M2 into A. Makes sense? Right. So what about the third scenario? So if I take the third block into consideration, that is M3. See, N3 is acting upwards, M3G downwards. I'm not concerned about it. I'm not showing it here because of the space constraint. But I hope you understood. N3 is upward, M1G is M3G is downward. Now, it is connected only to one string. So T2 on M2 is acting in the leftward direction. So T2 was this side. So here T2 should be in the rightward direction. So this will be positive and acceleration is also in the rightward direction, which is positive. So what will be the required equation? T2 will be equal to M3 into A. So basically you have linear equations. So when you add everything, T1, T1, T2, T2 will get cancelled. So all that you're left out with is F is equal to sum of these three masses, that is M1 plus M2 plus M3, the whole multiplied with A. So what is going to be the value of A? A will be equal to F by M1 plus M2 plus M3. And what is going to be the value of T2? What is going to be the value of T2? T2 is equal to M3A. So it will be M3 into what is A? Take this and substitute it. It will be F divided by M1 plus M2 plus M3. Similarly, what is going to be the value of T1? How much? So T1 is equal to, observe, can I write T1 is equal to F minus M1A? Can I write it as F minus M1A? F minus M1A. But what is A? So it is going to be F divided by M1 plus M2 plus M3. So when you solve this, you will get the answer as M2 plus M3 into F divided by M1 plus M2 plus M3. Okay. So this is what you will get. Okay. I'll tell you how to find this even without writing these many steps. Okay. So I'm expecting you observe something important in this problem, in these problems. See, if you look at the first problem, if there is one string that is pulling the block, the answer is A is equal to force divided by mass of that block. If there are two blocks, it is acceleration is force divided by sum of those two blocks. Why is it sum of those two blocks? Because you connecting those two blocks with the help of an inextensible string is equal to connecting those two blocks together with the help of some sticky force. So you take this block and stick it together, it will be the same acceleration. No, F will be equal to, you can directly write it in one step. F will be equal to M1 plus M2 into A. A will be equal to F by M1 plus M2. We can avoid all these steps. Right. In a similar way, if you look at the third one, what is acceleration? The net force divided by sum of all the masses. In a similar way, if there are even 10 blocks that are connected, acceleration directly you can write it. Force divided by sum of all the masses. Right. A is equal to F divided by sum of all the masses. That is the acceleration of each block. Okay. Now, I told you, with respect to tension, you can directly write it even without doing all these steps. How you can write is, if you observe, this is M3, M2, M1, F, right? So F is actually pulling how many blocks? 3. That is why F is equal to M1 plus M2 plus M3. For all these blocks, it is giving the same acceleration A. Now tell me one thing. Here the tension is leftward, here it is rightward. No. Let's break this part of the network. If this is gone, T1 is pulling how many blocks? 2 blocks. So can I write T1 is equal to M2 plus M3 into A. But what is acceleration? M2 plus M3 into F divided by M1 plus M2 plus M3. First of all, tell me, how did I directly write it as M2 plus M3 into A? Because this tension is doing the same job that is done by F. Is that clear? Now, here what is happening? Here it is T2 and here it is T2. If I break the network here, this T2 is pulling how many blocks? So T2 is equal to M3 into A. It is pulling M3. M3 into A, that is F divided by M1 plus M2 plus M3. Suppose the same question comes in MCQ, you need not sit and do all these things. Just use the logic and then proceed. So look at the way the answers are matching or not. A is equal to F by M1 plus M2 plus M3. A is equal to F by M1 plus M2 plus M3. T1 is how much? M2 plus M3 into F divided by M1 plus M2 plus M3. T1 is equal to M2 plus M3 into F divided by this value. Similarly, what about T2? M3 into F divided by M1 plus M2 plus M3. I hope you could understand. So you need not sit and solve the whole problem, but it is important for you to know why we got this result. So when it comes in subjective, you need to do or show all these steps. If it comes in MCQ or assertion reason based question, any of the objective type question, you can just go with this. Is that point clear? So maybe you can call it a shortcut or whatever it is. Just write down the heading as shortcut to solve the problem. Done? Okay. So till now we solved all the problems with the help of horizontal surface. Right. So the next type of problem that we'll see is what happens if the surface is inclined. Let's observe the same kind of a scenario with respect to an inclined surface. So when I talk about an inclined surface, it will be something like this, right? There is an inclination made by the surface with respect to the horizontal, and let's call it as theta. Okay, let's call it as theta. Let's say on this, there is a block of mass m that is placed, for which we are interested to calculate the acceleration. Is that point clear? Okay. So if I take this surface, okay, if I take this surface, if I place the block here, or okay, I'll place it like this. If I place the block here, you can see that as I keep making an inclination, it is not sliding, right? But so one point, it is starting to slide. You're able to understand? So what is happening in this direction is what we are going to see. So what you are actually seeing is this diagram. If you observe it like this, it is looking in a different perspective, right? But actually the diagram that I drew on the board is like this, means you're only seeing the side view. So that is why I drew this line and the horizontal line. And this is the block that is kept on top of it. Is that point clear? Now, having said this, right? Having said this, now what are all the forces that are acting on this? That's what we need to find. Now, I told you, that the object started sliding down. It started accelerating. Did you observe? It had a sudden motion. So it was accelerating from 0, its velocity increased, right? So the question is, what is the acceleration struggled, or sorry, what is the acceleration experienced by this block? For that, again, what are we supposed to do? We need to draw the free body diagram, right? So if I take this block and place it like this, right? This is going to be M, right? So what is the force that is acting downward? It is its own weight mg in the downward direction. Now, if the inclined surface is like this, if the surface is like this on which the block is in contact with, how will the normal force be? It will be perpendicular in this direction. So unlike the previous scenario, the normal force is going to be in this direction. Make sense? Here. See, this is where I want you to be careful. In the previous two scenarios, sorry, in the previous three scenarios, what happened is, if you took the normal force upward, the weight was acting downward exactly. So that they both got cancelled out because they're in the same line of action. Whereas here, what will happen is, in this case, mg cannot cancel the normal force. Why? Because it is not acting along the same line of action. It is inclined. So what we are supposed to do is, we need to resolve either of the forces into their components. So what are we supposed to do? Break it into their components. Just to recollect the concept of components, if this is taken as vector A, if this is going to be theta, then this A is broken into two components. What are they? X component and Y component. How will you decide that whether the X component is positive or negative? So how will you decide? Depending on the direction into which the arrow mark is passing. The starting of this arrow mark is considered as origin. From there, if you look at the direction of arrow mark, it says it is entering into the first quadrant. So for first quadrant, X is positive, Y is also positive, right? So first thing sorted. Next thing is, magnitude of this vector is A and this is theta. So when you resolve it into two components, you get A cos theta and A sin theta. Those are the two perpendicular components. So here, what is cos? Wherever theta is there, that is cos. And wherever theta is not there, that is sine. Did you understand? Wherever theta is there, that is cos. So I'm going to use the same logic here. Okay, listen to this carefully. Just for understanding, I'm taking this to be theta. Right. Now, if this is mg, I need to break it into two perpendicular components. One component like this and the other component like this. Why I'm doing like this is because, so I will show you again. Mg is taken like this, no? One of the components is going to be in the direction along the line joining N. So I need to draw one of the components in this direction. For the components, I'll use another color. Observe. So this is one of the components which is taken perpendicular to whom? Perpendicular to the surface. It is taken perpendicular to the surface and in the direction opposite to normal. Right? This is where we need to be careful. Observe. If I just extend it like this, mg is acting perpendicular to the horizontal. So here it is 90. So how much will this angle be? This angle. So it will be 90 minus theta. I didn't say it is 50 degrees for you to say it is 40. It is theta. It is theta, that's it. So it will be 90 minus theta. Got it? So it is 90 minus theta. But tell me one thing. If this is one of the perpendicular components, how is the other perpendicular component? It is like this, right? Now, if this is 90 minus theta, how much is this? So this line is parallel to the inclined surface. Listen to this carefully. If this line is perpendicular to the inclined surface, this vector will be parallel to the inclined surface because whenever you resolve the component, you resolve them to be perpendicular to each other. So if you took one of the perpendiculars to be perpendicular to the surface, where should the other be? It should be parallel to the surface. So if this is parallel to the surface, this line and this line are parallel to each other. So if this is 90 minus theta, how much will this be? It will also be 90 minus theta because it forms corresponding angles. Parallel lines and the transversal corresponding angles are going to be 90 minus theta, right? Since this vector and this vector are perpendicular to each other, how much will this angle be? See, this whole angle is 90. Out of that 90, 90 minus theta is gone. So how much is left out? Theta. So to put it simple, right, next time onwards, you need not sit and do this much. mg is going to act downwards. Mg is always resolved into two perpendicular components. How will you break them? One perpendicular to the surface, one parallel to the surface. So the angle between mg and the component perpendicular to the surface will be theta, provided the angle of inclination is given at the horizontal. Suppose in a problem, they give the angle of inclination here, things will exactly be the reverse. So as of now, I'm only telling with respect to the, taking the angle of inclination with respect to the horizontal. So I'll come from the beginning. If the angle of inclination with respect to the horizontal is known, right, at the vertex, right, if you know that, if the perpendicular, if the weight component is known, weight component is resolved. That is, mg is resolved into two perpendicular components, one perpendicular to surface, one horizontal to the surface, sorry, parallel to the surface. Now the angle between mg and perpendicular component will be theta. You can directly write it. You need not sit and do that. You need not sit and do all these mathematical operations repeatedly. So if that is theta, now tell me, what is this force going to be? Now, if I draw a separate diagram, okay, if I just, since I know the values now, if I draw a separate diagram, I told you that this is mg. How much is this? It is normal. This is going to be theta. Now, if this is theta, this is going to be 90 minus theta. Okay. So if this is mg, here there is theta. Using the same logic, what should I write here? What cos? Mg cos theta. So if this is mg cos theta, this will become mg sin theta. Right, this is going to be mg sin theta. Now, I told you this is the first step. What is it? Drawing the free body diagram. What is the second step? Assigning the directions. So when you need to assign the directions, in the previous cases, the surface was horizontal. The surface of contact was horizontal. Here, the surface of contact is inclined. So there is no rule saying that you should always take x-axis along horizontal and y-axis along vertical. Okay. So whenever it comes to physics, you can always take the coordinate axis according to your convenience. In this case, what I'm going to do is, I will say that the axis is also inclined like this. Means parallel to the surface, I'll consider it as x-axis. Perpendicular to the surface, I'll consider it as y-axis. So if I take this to be x and this to be y, observe. Again, one more point to be noted is, whichever you want to take it as positive, you are free to do so. You're free to take whichever direction you want to take it as positive, but you should exactly take the opposite direction to be negative. If you miss that, your answers will change. So in this case, since the object is, I always do or take the direction of acceleration to be positive so that my job will be easy. So in this case, this is the acceleration direction. So what I'm trying to say is, I'll take this direction as positive, means whatever force is acting in the direction downward with respect to the inclined plane is positive. So here, which force is acting along the inclined plane? Mg sin theta is going to be positive, right? Whereas with respect to y direction, I have nothing to do. So here I'll take y upwards as positive, downward as negative. So here this is positive and this is going to be negative. So here, what are all the forces that are important? Mg sin theta, n, and mg cos theta. Mg is not needed. In this problem, it is not needed because mg is already resolved into two components. Are you able to understand what I'm trying to say? So along the y direction, what is happening? Along y direction, what is happening to the system? Is it moving or is it balanced? It is balanced. Along y direction, there is no motion. So you can directly say n is equal to mg cos theta. This is a very, very important relation that you need to remember. We'll be using it in a concept of friction. So n is equal to mg cos theta. I hope you understood why is it so. Because there is no acceleration in the y direction. Whereas along the x direction, what is happening? The object is accelerating. It is moving down. You saw that the block slided down, right? So what is the acceleration with which it started sliding down? It is mg sin theta. So mg sin theta is the one which, sorry, mg sin theta is the force. Mg sin theta is the force which created an acceleration of A. So sum of all the unbalanced forces is equal to mass into acceleration. M and M are gone. A will be equal to g sin theta. So this is the acceleration with which the object is sliding down. So in this case, you can remember the final results. So along the inclined plane, if it is a smooth surface, here I didn't take friction into consideration. Here, one point to be noted is here it is a smooth surface. Right here it is a smooth surface. So with respect to a smooth surface, what is the acceleration experienced by the block that is based on it? If at all it is moving, what is the acceleration of it? It is g sine theta, where theta is with respect to the horizontal. Don't forget that. In a problem, if they change it with respect to vertical, you just need to write the complementary values. You should not write sine theta, you should write cos theta, about which we'll see later. But is this context clear? Is this clear? Right? This is a very, very important concept. Please make a note of it. Make a note of the point theta with respect to horizontal. Just like the So Surrounding, any doubt, any questions? All clear? Okay. Yeah, then we'll wind up.